Hello everyone, my name is Ze Yao from Mechanical and Material Engineering Department. My advisor is Professor Yan Wang. Our research is focused on recycling of non-metallic components in automotive lithium batteries, and the target material is graphite. The project is funded by the AMI Research Lab. Here's a research background. In 2023, more than 400 kWh of lithium batteries were demanded, which means over 3 million tons of graphite were used. As we all know, graphite is an irreversible product from nature and has uneven distributions around the world. What was worse, graphite has been listed as a limited export resource from countries of supply, and it is estimated that 3 billion batteries are thrown away by Americans each year. So as you see, it is quite important to recycle the graphite to build a healthy and sustainable market. To realize the aim of graphite recycling, we need to know what exactly exists in graphite as impurities. Then we can develop corresponding techniques to purify the graphite. If pure graphite can be obtained, the final recovery step will be taken to bring graphite back to the lithium battery market. For deliverables, we currently have one patent and one submitted paper. We will also draft a detailed report and send the recovered graphite to the AMI Research Lab for test. Now let's come to the experimental part. After we got the initial graphite from the leached black mass, we find the impurities are polymers, papers, transition metal oxides, and aluminum oxide. So first, we did the sieving process to separate the polymers and the papers. Then we used an acid leaching step to dissolve all the transition metal oxides. Finally, due to the strong covalent bond that makes aluminum oxide hard to dissolve, we innovated a sodium hydroxide sintering process. By utilizing the high activity of the molten sodium hydroxide, the impurities were completely removed. Notably, the excess sodium hydroxide and all the side products can be utilized in different fields. Characterizations were followed to confirm the successful purification process. Through the SEM images, we can clearly see the transition metal oxides and the aluminum oxides here during the recycling process. And finally, all the impurities are gone in figure E and F. The XRD results in figure G shows that crystallinity was not affected by the recycling process, and the figure H shows that the purified graphite delivers a purity of over 99.99%. However, the electrochemical performance of the recycled graphite is not satisfactory. As shown in figures C to E, the recycled graphite samples delivered much lower initial Coulombic efficiency and stability compared to the commercial graphite, which will lead to the lower energy and the shorter cycle life in practical usage. So the recovery process is essential, and let's come to the recovery part. Herein, we developed a novel service modification method to recover the graphite. Here, figure A shows the modification process, and figure B shows the recovered graphite, the SMA images, with a much smoother surface compared to the previous results here. As a result, the initial Coulombic efficiency and the cycle stability were dramatically improved, as shown in figure C here, and excitedly, as shown in figures D and E, the recycled graphite-based fuel cells delivered comparable capacities with the commercial graphite-based. And after increasing the current density to 0.5 C, the recycled graphite-based fuel cells proceeded a 10% higher energy density and a more stable cycle life, as the recovered graphite had better rate performance. The cost of the method was also evaluated here by adding graphite to the hydrometallurgical recycling process. The revenue is 17% higher, and the profit of recycling 1 kilogram of MC111 graphite-based battery increased from $1.89 to $3.5. It's almost doubled. Moreover, our method has the lowest greenhouse gas emission compared to the traditional methods. In summary, we completely purify the recycled graphite, recover the graphite with advanced methods, and the fuel cells with recovered graphite delivered enhanced cycle performance. Meanwhile, our method has proven to be environmentally and economically feasible. Thank you.